Hello and welcome to the second in a series of podcasts I'm hosting for WEG UK. For this discussion today, I'm joined by Mark Newman, WEG's Business Development Manager for End Users. Mark, welcome. To start, could you please give us a brief look at your background and what your day-to-day focus is as Business Development Manager for End Users?
Certainly, thank you, Andrew. My background started actually is with an education in mechanical engineering, and I feel that's actually been very helpful despite a career in the electrical world, because it's helped me understand the process that a lot of the customers are trying to achieve and trying to go through.
I suppose that's quite important, really.
It is, if helping them to solve their problems, it helps if you actually understand them in the first place. So that's been fairly critical. From university, I actually had a brief stint in the oil and gas sector, where I worked in measurements and logging while drilling in offshore locations in West Africa, North Africa, Italy, and the North Sea. And from there, I joined Japanese organisations in electrical power conversion. And I worked with them for 20 years, honing the skills and understanding of the electrical power conversion systems. And 18 months ago, I joined WEG as Business Development Manager with an end user focus. And what that means is I'm supporting operators of assets within the UK across industries, whether that's in pharmaceutical, oil and gas, mining, aggregates, anyone with large power demands essentially, and trying to support them in their electrification and ultimately decarbonisation journeys.
Well, good luck with the new role. 18 months, you're sort of still relatively new, but I'm sure you'll do a fantastic job there. People often use the terms energy transition and energy revolution interchangeably. In your view, is there a distinction between the two, and where are we currently in that journey?
I think revolution tends to imply something that's happening rather rapidly. I think that we're more in a transition, to be honest. We're transitioning because we have existing assets that are still generating, but we're layering on top of that new generation assets, particularly wind and increasingly solar in the UK, which are complementing the historical generation. A lot of the old generation is now being turned off as we scale the renewables. But I think it's definitely a transition, not a revolution.
And as we move through this transitional phase, what are the primary growing pains and or challenges that this shift is creating for our traditional electrical networks?
Well, the traditional power generation was based around a lot of large synchronous rotating generators. And as we layer on top the renewable generation, we lose a lot of that rotating generation, which provided three core pillars to the grid, which is inertia, which is voltage support, and short circuit current capacity. And those three pillars are very important to the grid stability. And the operator of the grid has to balance both demand and the supply side every minute of the day. And as we lose the synchronous generation and the grid becomes so-called weaker, the influence of the consumption on that grid has a bigger effect on the stability of the network as a whole.
It's quite complex, isn't it?
It is very complex. It's something that we expect to happen. We expect the lights to stay on, despite what we're doing in the background and how much demand or supply there is available at any one point.
I would suggest that most people, most laymen, would just suggest that electricity is electricity. So however it's generated, it can be supplied, but that's not actually the case.
It's not quite as straightforward as that. You must match supply and demand, and that is a balancing act that the operators have on a minute-by-minute basis.
So it's clear that the energy transition is a massive multi-layered puzzle. But before we look at how the national grid is changing, let's look at the individual user, because as we know, the greenest energy is the energy we don't use in the first place. So So how is WEG helping existing end users with demand side efficiency? How does simply being more efficient support the broader transition?
Well, you're quite right. Energy efficiency is probably the simplest lever that we have in terms of reducing demand side requirements. And what we're trying to do, and my role in supporting end users, is to understand what technologies we can introduce into their existing process, their existing facilities, in order to be aware of where they can influence pure electrical demand and where they can also influence their own processes and procedures to have a higher output, higher yield of their own product from the energy that they're consuming at the time. So it's in looking at efficiency and looking at what technologies can support that efficiency, not only from an electrical perspective, but from an entire process point of view.
So very much an advisory and consultative role as well, really.
Absolutely, absolutely. We're the electrical experts. We deal in electrons, but we can also understand what influence that may have further down the line.
But what specific technologies then does WEG already have in its locker that will help businesses electrify their operations and reduce their carbon footprint today?
Well, staying with efficiency, we have some of the most efficient motors on the market. We've continued to develop a very traditional technology in order to drive efficiency, and we achieve levels of IE5 with conventional induction technologies. We achieve what will be IE6 levels of efficiency using permanent magnet as well as conventional magnet technologies and variable speed drives. We also have variable speed drives at higher voltages to be able to apply to larger applications. We are developing high-speed motors so that we can replace mechanically driven applications such as gas turbines, steam turbines, with electrical devices. And on top of that, we have battery energy storage technologies which can help to optimize their power consumption within the plant. And also EV charging.
Of course.
So in their own car parks for their own cars, but also if they have larger fleet operations, we also have those technologies, power conversion technologies within our portfolio.
So you've got a broad range of a broad traditional product range, which is being complemented by new and additional products that serve this market sector.
Very much so, yeah.
Excellent. So we've covered efficiency for the end user, but even with the best efficiency, we still have a stability problem, I guess, when we shift to renewables. I want to dive into the heavy infrastructure side of the WEG portfolio. So a common concern is that switching to renewables can reduce grid stability. Why is that the case, and what do we actually lose when traditional thermal plants close down?
So there's three main elements that we lose. One is inertia, and inertia is essentially the grid's ability to react to a frequency response. And the higher the inertia, the slower the reaction to any change in frequency. There is the voltage stability, which is essentially a balance of active and reactive power being generated in the network. And then the third is short circuit capacity, or fault capacity, as it's also referred, which is a grid's ability to cope with a short circuit event. If it's what we call a strong grid, then it's able to cope better with a fault without it tripping out and then having blackouts. And we all know what the unfortunate impact of blackouts could be.
Indeed, indeed. So in terms of solving a problem, for those of us who aren't electrical engineers, could you explain the role of synchronous condensers? What do they actually do to keep the lights on?
So synchronous condenser, first of all, what is it? It's not a motor because it's not driving anything. It's not a generator because it's not being driven. So essentially it's a synchronous machine that is spinning, and it is able to deliver the three elements of grid stability that are missing from renewable generation assets. So it can deliver inertia, it can deliver active and reactive power to the network for voltage support, and it can deliver very large quantities of short circuit current in a very short time frame. So what it allows the network operator to do is call upon the services of a synchronous condenser asset to stabilize the grid in the event that they are seeing instability, which could be caused by a whole host of reasons. A synchronous condenser can deliver all three of those, or any of those at any one moment, depending on what the network operator demands.
So it's essential for integration of renewable energy into the existing network, is it?
It is, in order to keep the network stable.
Okay.
And it allows the network operator to call upon those services to ensure that the lights stay on.
And that obviously links into BESS, battery energy storage systems, I guess. So they complement, do they, synchronous condensers to create more resilient grid?
They can do, certainly. With the inventions of grid forming capability in the inverters of battery energy storage technologies, they are able to support grid stability by providing synchronous inertia as well as frequency support and response services. So yes, they are, with the more modern technologies involved in the inverters that they use, able to support grid stability as well as offer the energy arbitrage opportunities to the operators that historical battery energy technologies have also been able to do.
Well, clearly these are, they're massive infrastructure shifts, I would imagine. What investments has WEG made recently to ensure that you can deliver these high-level solutions at scale across, well, I guess Europe as well as the UK?
Yeah, well, WEG, we're a Brazilian organisation, so a lot of our mother factories are in Brazil, but we manufacture across 66 different sites in 18 different countries currently. For these particular technologies, we are investing in Brazil at the moment. We've got a 1.1 billion real, it's about $220 million US investment in a new synchronous facility producing the large synchronous condensers that I mentioned, as well as producing high-speed two-pole synchronous motors, which are in support of decarbonisation efforts as well, when you're looking at replacing conventional turbine-driven loads. So that's an investment on the synchronous rotating machine side, but there's also a facility being developed to be able to deliver 2 gigawatts of battery energy storage solutions per year alongside that. So whilst we've got the technologies existing within our portfolio, and we've got proven projects in the Southern American territories, we're bringing those products across into the European markets, and along with our local support partners and our engineering firms to be able to support the execution in the UK and Europe, we're able to bring those solutions across, and when those factories are up and running, we'll be able to do it at even larger scale than we are today. So
I guess that covers the business case, or if you like, the bankability in terms of energy projects are huge capital investments. So I was going to ask, how does WEG's involvement help with the bankability or the financial security of these long-term transition projects, I should say?
Well, I think the challenge of the industry is not technology. The technology's there. It's getting the projects to a position where they can be executed. And a lot of that comes down to so-called bankability. Who's going to pay for them? There's money there, there's investment will. And so WEG as an entity are trying to position ourselves as a trusted technology partner to be able to deliver the right technology to the right projects in the right part of the world on time. And that should help overcome some of the hurdles that the projects have in getting off the line, reaching final investment decisions, and achieving the necessary financial targets to press play.
Well, that leads quite nicely on to my last and final question, really, where I was suggesting that looking at the road ahead, what's WEG's ultimate vision for its role in the global energy landscape over the next decade?
Interesting question, actually. So all the work that we're doing is in support of electrification. We do see that as the future, and the more efficient we can make that, the more effective we can make the generation of the power through solar technologies, wind technologies, the inverters that are associated with them, battery energy storage technologies to support that, as well as trying to deliver some of the grid stability services that we're losing through conventional generation. I think WEG are trying to position themselves as technology partners in that journey. We are more than a motor manufacturer that perhaps people historically have known us for.
Absolutely, yeah.
And I think that once the markets realise the breadth of our portfolio and our competencies, we'll be able to engage more actively with projects in this part of the world.
And are you hopeful, particularly with the UK, are you hopeful that that progression will be fairly rapid in that journey?
It has to be. Otherwise we're going to miss every target we've ever tried to set ourselves.
Yeah.
And the government, with their Clean Power 2030 objectives and the network operators' responses to that, indicate that yes, this is something that will happen. And we're seeing similar signals across Europe. And I don't think it's in any doubt that it'll happen. It's just at what pace.
And at what level of investment governments, I guess, are prepared to put into their infrastructure?
Yes, indeed. The government investment is necessary for progressing newer technologies. But there's a lot of technology out there already that we can use. And there's a lot of financial investment will out there as well. I think rather than it being a money issue, I think a lot of it comes down to policy and ensuring that we modernise the grid in a way that can support all of the necessary projects to get us to the net zero dream that we all have.
Well, hopefully we can do that. Fascinating stuff. Thank you so much. Thank you, Mark. Thank you for joining me.
Thank you.
Well, that brings to an end the second in our series of podcasts by WEG UK. Should you want more information on anything that you've heard today, please contact one of the team members or indeed visit the website. Stay tuned and watch the next one in due course. Thank you.